Hello everyone and welcome back. So let's take a look and see how we can implement this idea. So I'm gonna start with a box just so I can illustrate this nicely and easily. I'm gonna create a box. I'm gonna VDB from Polygon. I just need points filling this. So density field, fill interior, and let's scatter a lot of points. Don't need to relax them. Okay. And let's create a curve. And I'm gonna do something like this. Okay, it's inside. I want to move it inside, so let's do transform. Something like this. Okay, so the idea is I want to transfer the point position, so I want to do this. I want to take each point and find the nearest point to it on this curve. So let's say this point here. Let's say this point is going to find this point on this curve. Once we do that, we can draw a vector that goes from this to this. Okay. This vector is going to give us two things. It's going to give us a direction and a magnitude. The magnitude of the curve represents the distance of how far that point is from the curve. Okay, so if this vector has a length of 10, that means this point is 10 units away. If the length of the vector is 1, that means it's very close. So we can use this to drive whatever force we want, and that way the closest point to the curve are going to be affected more, and the further away it gets from the curve, the less effect it will have on the point. Okay, this is great, but then what about the rotation section? How are we going to take a rotation? Well, if we take the vector from here to here and an up vector and do a cross product, it's going to give us a rotational vector. Okay, it's going to give us a vector that rotates around the curve. This is the nature of the cross product. What we can do then, we can take that rotational curve and we can take another one that points from this point towards the nearest point on the curve, which will make the point gets closer. Okay, so if this one is here and it's pointing toward the curve, we can have a force that pushes it towards the curve to get closer. And by mixing this, we can have them get closer to the curve and rotate, swirl around it. Okay, and with that multiplier that is based on the distance, we can get a nice decay of the force, so it only affects the nearest point, not everything. So let's do all of this and see how it works. So let's create a point VOP. And I'm going to resample this curve because I need a lot of points. And I'm also going to convert it into a subdivision curve to get smooth curvatures. And let's connect this into the second input. Let's dive inside. And we're going to use a point cloud lookup as well. So point cloud open. And I want to open the second input, and the point position is the first. So we're going to take all these points. We're going to do a point cloud lookup on this and find the nearest point. Let's put a PC filter. And I want to query the point position. So each point now will get the information about where is the nearest point to it. I'm going to increase the radius to 1, set this to 50. And now we have that information. We can do what we can do is we can subtract the current position from this new position and export that as the normal so we can see it. And boom, see, we're getting something interesting. And if we increase the radius, we will see that all the points will always get, a point. And this, because these points don't have any result, they're just getting something random. So we need to make sure that we have enough coverage, and then the less points look up. Sorry, the lower the number of points, the faster the result, but we may not be able to capture everything we need. So 50 is fine for now. And then what I'm going to do is I'm going to take this n and add it to the current position. So I'm going to move the points along this new vector. Let's disconnect this and let's move them. And let's multiply this by a constant so we can play with the offset. And if we move them, you will see that they're getting away from the curve. We don't want that. We want the inverse of that. So I'm going to negate this vector. Okay, and if we play now, they should get closer to the curve. See, they're all getting close to the curve. The higher, the closer, all the way to basically hugging it and overlapping on top of it. Okay, so great. We have this vector, and we can use this as a force. So the next one is we want this cross product, the rotational force. Okay, and that is going to come from this. So if we take this vector here and normalize it, because we don't care about the magnitude at this point, and compute the cross product of this, and then plug this into n, and let's visualize n. Sorry, not the color. You'll see it's a rotational vector. So if we mix both of these, and let's normalize both of them. I don't need the distance. So I'm gonna combine, or let's use this first so we can see the result of the cross product onto the points. So if we move this, you will see that the points start to rotate and then converge and drift away. And that's normal because a rotational force is going to do that to the points. And what we need to do is we need to mix them with the incoming, or with the force that is pointing inward, and that way we get both of them, both of the features. So you see now the points are rotating around the curve and getting closer to it. Okay, and the last thing we need is we need to compute the length of this distance. So length of this vector, and let's plug this into the color. You see the center is black and the further gets away is white. So we need to invert this fit range, and I want this range to go from 1 to 0, and we can lower this to make sure that the curve only affects the closest point to it, and then we use this as a multiplier on top of the force that we made, and that's it. Now if we play with this, it will only affect the points that are very close to the curve. So we're going to do all of this inside the inside pops, and the next thing we need is some curves for this system to work. So what we can do is we can do a quick sim using less points. So I'm going to copy this. It doesn't have to be an exact sim, it can be anything really. So let's lower that. I don't need too many curves. And I'm gonna dive inside and say emit one time. I'm gonna have them live for 4 frames, and I'm gonna use all the points, and $f is less than 2, so it emits 1 frame and that's it. And if I hit play, I get these curves at these points moving. Great. So let's do this. I'm gonna copy the DOP import. I'm gonna drag and drop this here, and I'm gonna trail the points. So let's try 50 frames, and then we have some nice curves. And let's put down in add node, and let's connect them by ID. And the reason the ID didn't work before, because it kept changing every frame, so it's not consistent. With this, we're only emitting 1 time, so it's consistent. Okay, so let's go further, and let's go back here. Let's increase this to 100. Okay, And I don't need all the curves, so I just did this to get some data. I'm gonna lock it so it doesn't change. Okay, and I'm gonna pick this curve, this curve, sorry, this. I don't want one with too many changes in it. I want this to be smooth. So I'm gonna blast these three, delete non-selected, and this is what I'm gonna use. And let's smooth them out. We don't need them to have a lot of details, honestly. We just need a lot of points, so we'll do that here. Resample. Okay, so this is what we're going to use for our sim. And this is our sim. And I'm gonna plug this, Shift L to align them. I'm gonna plug this into the third input. And it's template. So we have 3 curves, okay. And let's dive inside, and we're gonna implement this similar to what we did in the graph. So I'm gonna disable this force and have the points only shoot upward. So in the streams and attributes, I'm gonna move them upward, and let's add some randomization just to get them going. That's all. Okay, and then we can debug and implement the system here, and then we'll continue in the next video. Thank you guys for watching, and see you in a bit.